right, so we're gonna talk about average speed today. So when you guys drive somewhere, let's say you're on the highway, do you drive the same speed the whole way? No, you don't. I mean, your parents don't, because you guys don't drive at all, but you're gonna slow down and you're gonna speed up and you're gonna slow down again and you're gonna speed up. And so the idea of average speed is just that idea. It's just it accounts for all of those slowdowns and speeds up. I haven't really said anything yet that's like deserving of a question. So unless you're super confused about what I just said, go ahead. That's a what if. Let's keep it in the box, Tyler. Okay. So the what if questions aren't usually ones that are gonna help us with the topic, right? So you know, like we speed up, we slow down, and so on. When we've done problems previously, we've been assuming that the same speed has been maintained for the entire duration of the trip. So we're going to be doing problems where you have to find the average speed of a couple different legs of a trip during this next part of the unit. Okay, so in these calculations, the speed varies through the exercises, and we're going to be writing this red down, you guys. They may start slowly, then get faster throughout the journey. So in these problems, we will calculate the average speed throughout the trip. Okay, makes sense? Okay, so let's do a problem. Marcella walked 100 meters in 25 seconds. Nellie ran the same distance in 15 seconds. What are their average speeds? Okay, let's take Marcella first. We're going to use a rate diagram today. So in 25 seconds, how far did Marcella walk? 100 meters. Okay, if we're finding speed, what goes on the left? Time or distance? Time. Time always goes on the left of our rate diagrams when we're finding speed, okay? So to set this up for Marcella, we'll make it look like this. In 25 seconds, she walks 100 meters. Okay, so we're gonna find her speed in meters per second. So all we need to do is divide by 25. And what is her speed in meters per second, right? 4 meters per second, great job. Okay, we need to make sure we include those speed labels for that too. All right, now let's find Nellie's speed. We already found Marcella's. Now we're finding Nellie's. All right, so Nellie runs the same distance in 15 seconds. Okay, so class, if we're finding speed, what goes on the left? Time or distance? Time. Okay, what is the distance that Nellie ran? 100 meters. Okay, so we're going to make it look like this. In 15 seconds, Nellie ran 100 meters, and we're looking for a meters per second. So what do we need to do now? Elijah? 15 divided by 100? Okay, that would look like this. Is that what you want? No, what do you want? Ashley? Yeah, so we're going to divide both sides by 15. So 100 divided by 15. Good. All right, and then we're just going to turn that into a mixed number. 15 goes into 100 6 times, right? And 6 times 15 is 90, with 10 15ths left over. And when we simplify, we get, oops, I shouldn't have put 90. I was just thinking about 90, but it goes in there 6 times into 100. 15 times 6 would be 90, so we would have 10 15ths left over. And then we simplify to 2/3 by dividing by 5/5. Okay, so our answer is 6 2/3 meters per second. Pretty clear? All right, do another one. Mr. Carlos ran 5 kilometers in 1/3 of an hour on the treadmill. Let's hold up for just a second. Let's figure out how fast that is in miles per hour. So 1/3 of an hour is 20 minutes, right, guys?
Yep.
5 kilometers, do you guys know how far that is? Yeah, Alex?
3.5 miles.
It's a little over 3. It's like 3.1. That's a pretty fast time, you guys. Yeah, he's trying to, wait, he's booking.
Yeah.
That's like a high school, that's a pretty good high school cross country speed right there. But for an adult, that would be really fast. Okay, so we want to find his speed on the treadmill. What goes on the left, time or distance? Say it with confidence. Time goes on the left. In 1/3 of an hour, he runs 5 kilometers. Now I want to know how many kilometers he runs in 1 hour. What do I do? How do I get from 1/3 to 1? I gotta do something like divide or multiply. Nora? No, try it. Just go for it. It's okay if you're wrong. Take a chance. Okay, we can't add. That won't work. Ainsley? We multiply it by 3. Great job. Okay, so we're multiplying both sides by 3 over 1. And in 1 hour, he can run 15 kilometers. He's booking. Okay. He's he probably is a very young. Either that or he's just really in shape. He's running through Costco in 2020 trying to get the last pack of toilet paper. Yeah. Okay. A van took 36 minutes to travel from one town to another. The towns are 54 kilometers apart. Calculate the van's average speed in kilometers per hour. Okay, let's label. We've got 36 minutes. That's our time. And they are 54 kilometers apart. That's our distance. We want average speed. We're looking for speed. If I'm looking for speed, what goes on the left? Time or distance? Time. What is it? Time. Okay, we've got 2 different methods we can use here. One's called the proportion method and one's called unitary. So we're going to start with the proportion. Okay, so we're going to assign, in 36 minutes, he's going to run 54. He's not going to run. He's going to drive 54 kilometers. Okay. So with the proportion method, basically this is just like mental gymnastics where you kind of find easy ways to divide or multiply where you can get to the end goal. And our end goal is 60 minutes. It's not very easy there's no direct multiplier or a whole number multiplier for 36 to get to 60, right guys? But if we divide 36 by 6 and 54 by 6 and take it down to 6 minutes, now can we get to 60 really easily? Okay, so I divided both sides by 6. I divided 54 by 6 and I got 9 kilometers. Now what do I need to do to get to 1 hour? Times it by 60. How do I times it? Why would I times it by 60? Finn, eyes up here. Thank you. I want to know how far he drives in 1 hour. Maddie. Yeah, we're going to multiply both sides by 10. So we always are multiplying both or dividing both sides, my friends, because we can't manipulate one side of an equation without doing the other. So we have to do both sides. But yes, let's multiply by 10 and we're going to get 90 kilometers per hour. Okay, so the unitary method. When we use unitary method, we take the left side down to 1. So if we're doing it that way, we're going to divide both sides by 36, and we're going to have a fraction over here on the right, which is fine because we can cross cancel. So let's divide both sides by 36. And in 1 minute, he will have driven 54 divided by 36, which if we simplify that or divide, we'd get 1.5 or 1.5. Now we need to multiply by 60 to get to 60 minutes. What are we going to do when we multiply both sides by 60? Or what will we get when we multiply both sides by 60? I'll give you a big hint, guys. We're not going to get a different answer. It's going to be the same. Okay. He goes 90 kilometers. So the answer is 90 kilometers per hour. Well, 90 kilometers per hour is only about between 45 and 50 miles per hour. It's not that fast. All right. The average speed of a car traveling from town A to town B. Do you guys have this? My notes are kind of messed up here. I changed them and then I just reprint them. Okay. Was 60 miles per hour. Town A is 36 miles from town B. Find the time the car took to travel from town A to town B. Okay, so we have a distance here of 36 miles and we have a speed of 60 miles per hour. So what are we trying to find in this problem? Distance, speed, or time? Time. Okay. So in this case now, what do we put on the right of the rate what do we put on the left and on the right of the rate diagram? Somebody raise their hand and tell me. Annie? Mm-hmm. Well, it's a no. So we're not directly going to use the speed, and here's why. Well, we do use the speed. 60 miles per hour. It looks like this: 60 miles per 1 hour. Time goes on the right. We are finding time, which is why we need to put it on the right. Does that make sense? Okay. So town A is 36 miles away. Okay. All right. So this is very similar to our last problem, right, guys? Remember how it was kind of a lot easier to use the proportion method? Okay, go ahead and solve the problem. You raise your hand when you've got the answer, guys. All right, Charlie, what'd you get?
I got 3660.
You got 36/60ths? Let's see. Let me think about that for a second. If we divide 36 and 60 by 6, we would get 6/10, right? Yep, that's correct.
Yes.
Okay, you just needed to simplify. So it would be 3/5 of an hour. So I think, so you did unitary. Okay. So on this one, I think the proportion method is easier because look what happens if we divide both sides by 10, we get 6 miles. It travels 6 miles in 1/10 of an hour. And now I can go from 6 to 36, super easy peasy, but just by multiplying by 6. And so I would get 6/10 of an hour. And then when I simplify, I get 3/5 of an hour. Okay. You guys ready to move on? All right. Oh, there's a whole lot of, okay. The average speed of a sprinter in a 400-meter race was 8 meters per second. How much faster would he run the race if his speed was 10 meters per second? What kind of question is this? If it's saying how much faster, what is it asking me to find? Time, distance, or speed? Mateo? Well, it gives us his speed though. So it gives us this speed and it gives us this speed when he's running faster. What do you think? Go ahead, Tyler. It's asking us to find time. So if I run a race faster than if I say, you know, I ran such and such a race in 10 minutes and the next time I ran it in 8 minutes, how much faster did I run the second time? 2 minutes faster, right, guys? So it's a time question. Okay, here's our distance is 400 meters. Okay, so if we're trying to find a time, let's go ahead and put time on the right. Okay, we're going to find this for both speeds. So for the first race, he runs 8 meters in 1 second. We want to know how many seconds it takes him to run 400 meters. What do I multiply 8 by to get to 400? Annie? 50, yeah, let's multiply both sides by 50, and it's gonna take him 50 seconds to run that race. Okay, in the second race now, we're still finding a time. Okay, so he's gonna go 10 meters in 1 second. You guys are copying this down? Where'd it go? There it is. Did I skip something here? Oh, no, it just filled it in. It took him 50 seconds to run the 400-meter race. We need to calculate how long it will take him at 10 meters per second in order to determine how much faster he would run. So here's how we'll set this up the second time. 10 meters in 1 second. We want to know how long it takes him to run 400 meters. What do we multiply by? Liam. We multiply by 40, good. So it's going to take him 40 seconds. How much faster is he the second time? Gage? Yeah, he ran 10 seconds faster. Make sure you're keeping your units with your numbers, Austin. Okay. All right, so now we're going to calculate the robot's average speed when it traveled from point A to point B. Okay. All right, so segment AB. So check this out. You got like this little map here, and he goes from A to B to B to C to C to D. Okay. Let's calculate his average speed from A to B. If we're finding speed, what goes on the left? Time or distance? What? What?
Time.
Okay. So, how do we know what the time is? Okay, where does it say? Alex.
On the top.
Okay, what does it say?
It says 50 seconds.
Okay, it says 50 seconds. I think I've got, it's 5.0, it's not 50. So in 5 seconds, he travels 125 centimeters. All right, so we want to know how many centimeters he travels in 1 second. What do I do?
Divided by 5.
Divide it by 5. So we're going to get 125 divided by 5, which is 25 centimeters per second. Okay, now we're going to find out how far it would be from A to C. You guys have this? And finish copying that down. And let's do the next part of the problem. Okay, so his speed is 25 centimeters per second. Oh, there we go. The robot's average speed when it traveled from point A to point C now, though, was found to be 16 centimeters per second. What time should the stopwatch say at point C? Okay, well, if he's traveling 6 centimeters per second, we want a time measurement, right, guys?
Mm-hmm.
Okay, so this time we're finding time. What we're finding goes on the right. So he travels 16 centimeters in 1 second, right? And you know what? I think I read this wrong. So we already know how far he traveled from, no, I didn't read it wrong. Okay, so he traveled from A to C, which was these two measurements together. So we need to find out his distance from A to C in order to figure out how fast he traveled that in. Okay, so what is 125 plus 75
200.
together? What is it?
200.
Okay, so he walks 200 centimeters. That's not very far, is it?
No, it's
It's like 2 meters. This robot's taken a long time to walk from A to C.
what's a robot?
Okay, so we need to go from 16 to 200. How should we do that? Any suggestions, Annie?
Find 1 centimeter.
Just divide by 16 for each and then multiply by 200, like use unitary. Yes, we could definitely do that. So if the average speed is 16 centimeters per second, 200 centimeters would take us 16 times something, right? To figure out what that multiplier would be, we would need to divide 200 divided by 16. Oops. And we would get 12.5. So here's another way to. Oh, nope, the next one is from point C to point D. Okay, so we know how long it takes to get to that one, 12.5 seconds. All right, so now it says, our next problem says, AD is 400 centimeters long. How fast should the robot travel from point C to point D for its average speed from point A to point D to be 12 centimeters per second? Okay, so when it says how fast, it's really asking us for a time. Okay, not for a speed. So we have a distance and we have a time. Okay, so, and we have a speed. So let's set it up. So in in 1 second, he's gonna go 12.5 centimeters. That's our speed. And it's not, my pen's not working. There we go. All right, since we're looking for time, remember time is on the right this time. Okay, can we go from 12.5 to 400 very easily? Well, we could. What's 12.5 times 2? Do you guys know? 25. Okay, let's multiply by 2. In 2 seconds, he goes 25 centimeters. Can we get from 25 to 400 more easily? Okay, let's stop off at 100. Let's multiply both sides by 4. So it's going to take him 8 seconds to get to walk 100 centimeters. Now what do I do to finish it off? Times 4. So it will take him 32 seconds to walk the full 400 centimeters. Okay, but the question was, how fast should the robot walk from point C to point D for its average speed from point A to point D to be 12 centimeters per second? What is this 32 seconds? Where is that from? Okay, think about what we just looked at. We had a distance of A all the way to D, right? That's the entire amount of time that he would take. Finn? You remember what the stopwatch said at point C from the last part of the problem, you guys? It said 12.5 seconds. Do we need to even divide anything? No. We just want the time that it took him to get from point C to point D. Yeah. Yeah, I have to subtract 12.5 from 32. Okay, let's do it in our heads. Who's got it? 32 minus 12.5. Do 32 minus 12 and then minus another half. What is it, Elijah? Well, 32 minus 12 will be 20. Now we need to subtract another half. Austin? 19.5 seconds. Great job. Okay. In your textbook on page 147, I would like you guys to do number 5, both parts, A and B.